Today we're going to use exponents, and these exponents are only going to be when we have a base 10. Okay, well, let's look here at our chart. We have 10, which is the same as 10 times 1. We have 100, which is the same as 10 times 10. We have 1,000, which is the same as 10 times 10 times 10. We have 10,000, which is the same as 10 times 10 times 10 times 10. But there's got to be a faster way for us to say 10 times 10 times 10 times 10, especially when that 10 is the same number. Well, the fast way to do that is to use something called an exponent. The exponent tells us how many times we use the base as a factor. So here, 10 to the second power, or 10 squared, is the same as 10 times 10. Notice how we're multiplying 1, 2 times by each other. Let's look here. So this was 10 to the second power. Here we just have 1 10. So this would be 10 to the first power because we only have 1 10. I could rewrite this as simply 10. 10 times 10 times 10 could be written as 10 to the third power because I'm multiplying 10 by itself 1, 2, 3 times. This could be written as 10 to the fourth power because I'm multiplying 10, 1, 2, 3, 4 times by itself. So what would be the exponent of this multiplication? Well, let's see. 1, 2, 3, 4. We have 4 10. So I'm going to write a 4 there. Notice how here this is the exponent. And this 10, this number that we keep multiplying by itself, we call that the base. We call that the base number. At reading exponents, we would read this as 10 to the second power, or 10 squared. We would read this as 10 to the ninth power, 10 to the ninth power. Let's go ahead and practice writing our exponent out using multiplication. Well, I know my base number is 10, so that means I'm going to have 10 multiplied by itself. How many times am I going to multiply 10 by itself? 5 times. 2, 3, 4, 5. So these two things are equal. Let's look here. If 10 to the third power equals 10 times 10 times 10, what would the product be? What would be the product? What would be the product? Well, let's see. 10 times 10 times 10. 10 times 10 gives me 100. And 100 times 10 would give me 1,000. So 10 to the third power equals 10 times 10 times 10, which equals 1,000. Now here we have a tricky problem. We have a very tricky problem. And in this problem, we're going to need to use our order of operations. So if you remember, parentheses, exponents, multiply or divide, whichever comes first from left to right, add or subtract, whichever comes first from left to right. So let's focus on this problem first. 3 times 10 to the fifth power. 3 times 10 to the fifth power. Well, 10 to the fifth power is going to be 10 times 10, 2, 3, 4, 5. So that's going to be quite a work. So 10 times 10 That's going to give me 100. Times a 10 is 1,000. Times another 10 is 10,000. Times another 10 is 100,000. So now I have 3 times 100,000, which gives me 300,000. The problem says find the difference between 3 times 10 to the 5th, which is here, and 21,600. Well, the difference means that we're going to subtract. So let's go ahead and line up our decimal point. If this had a decimal point, it would be here. So then we have 21,600 here. We're doing the difference, so we're subtracting. 0 minus 0 I can do. 0 minus 0 I can do. 0 minus 6 I cannot do, so I'm going to regroup. This is 10, now it's 9. This is 10, now it's 9. This is 10. 10 minus 6 is 4. 9 minus 1 is 8. 9 minus 2 is 7. 2 minus nothing is 2. Our difference is 278,400. 278,400. Let's go ahead and work on our problem set. But remember, the exponent just tells me how many times I multiply that base number by itself. So, looking at our problem set, write the following in exponential form. That means with exponents. So 1,000 I could write, well, I know it's 10 times 10 times 10. This is not exponential form, but that's going to help me figure out my exponential form here. This would be 10 to the second power because I have 2 tens. This would be 10 to the fifth power because I can even tell by looking at the zeros. Ooh, look at that. Here we would have 10 to the third power. Here we would have 10 to the sixth power, 10 to the fifth power. Okay, looking at number 2, write the following in standard form. Well, this is going to be 4 times 1,000, so that's 4,000. Remember, standard form is how we typically see numbers. This is going to be 64 with 4 zeros behind it. 1, 2, 3, 4. 640,000. Oh, we're dividing. That's going to mean it's going to get smaller. So this is 5,300 divided by 100. This is math we've done already though, guys. If I do that, I move my decimal 1, 2 times to make it smaller, getting 53. Here I'm dividing by 1,000, which means I'm going to move 1, 2, 3 times, and I get 5,300 in standard form. Remember, we're dividing by 10, which makes it a power of 10, which makes it a smaller number. Here I'm going to move that decimal to be bigger 1, 2, 3 times, so my answer is 6,072. It's going to get bigger 4 place values, 1, 2, 3, 4, so 6072. There's those other 2 place values. And I come back 1, 2, 3 numbers, I put my comma. This is going to get smaller by 1, 2, 3 place values. So I have 948,000. 948,000. Which of the following expressions are equivalent to 1,000? Select the 2 correct answers. Well, let's see. This one's correct. 10 times 10 is 100 times 10 is 1,000. That means that this one is correct as well. Number 4, what's the correct way to say this? We would say 10 to the 8th power. 10 to the 8th power. Find the difference between 4 times 10 to the second power and 200. So that's going to be 4 times 10 times 10, which is 4 times 100, which is 400. So 400, now we have to do the difference, minus 200 is 200. Find the difference between these. That's 8 times 10 times 10 times 10, which is 8 times 1,000, which is 8,000. The difference between 8,000 and 5,000 is 3,000. And that's it for today. Remember, the exponent tells me how many times I multiply that base number by itself.